Let's start our first project in machine learning, the simplest data set available on Kaggle, and which is student exam performance prediction. I'm sure everyone can connect to this. It's all about exams and your results, right? This tutorial is for complete beginners. In fact, for the ones who are starting with machine learning and want to dive with hands-on learning. You are with me, Anuradha. Welcome to my channel. And right now I'm on Kaggle. I'll be sharing this link in my comments. For now, I'll just download this data, make it available on my local drive. Further to that, Google Collab to get started with my work. You can use Jupyter Notebook if you're comfortable with it, but Google Collab is the best way to start with. Very easy to. So I'll just name it over here, student performance. I have to connect it to runtime host, which will help me to run my code. It says too many sessions because I already have one session running. What I'll do, I'll just disconnect with earlier ones, and here I am. So I'll try to connect with this again. Now once I'm connected, I will go over here, and wherever I have downloaded my data, I will pick it from there, and it gives you warning that once this runtime is gone, your data will be gone, so you need to save it somewhere. And we'll be talking about Mount in Google Colab somewhere in time, but right now we'll just upload it and to get set started. And if you find that your runtime is disconnected, just re-upload it again. For now, first line, I'll just do import libraries. The way to enter biggest heading. First and essential machine learning library is pandas. Okay, so I will import it. Now let's have a look at CSV, which we just downloaded. I'll open the local copy. If I have a look at this data, this is in CSV format, and it has two columns: study hours, which contains some decimal values, and previous exam score, which again contains decimal values, and then we have a status pass fail column, which has two values, 0 and 1, and I guess 0 is for fail and 1 is for pass. How do we make this data available to machine learning algorithm? So what is machine learning algorithm? It's a model, right? It's a set of methods, you can say, which learns from training data patterns, and then finally it takes action or makes predictions on unseen data. And this is binary classification problem. Now let's close this and go back to Google Colab. So we imported pandas, and now we will be loading our data, which is in CSV. Okay, and we'll be loading this data in a data frame using pandas. PT, since our structure is CSV, read underscore CSV method from pandas, and we'll be giving the file path here. Since my file is in same directory, I'm giving this. Now all good. I got a tick over here. That means it is executed successfully. But how do I validate that my data is loaded, and what is the structure? So let's see the type of DF. So it gives pandas core frame. Data frame is a data type, right? So we have a data type int, we have a data type string, float, and similarly this data frame is a data type. And it is a data structure that contains rows and rows and columns, and each column can be a series object. And what we can do with the pandas is a lot of things. We can visualize data, we can explore data, we can do multiple operations on data. Okay, and we'll be using these methods as and when what are requirement. So first requirement is to see how many records are in this data, and for that I use df.shape, and it says 500, 3. 500 represents number of rows and 3 represents column. I want to see how my data looks like here in this data frame. So what I'll do df.head, and it fetches me top 5 records. If I would have done df.tail, it will be fetching me bottom 5 records. Or if I do df.sample and in bracket I give, let's say I give df.sample and in bracket I give 20, so it will fetch me random 20 records, and so it will fetch me 20 records from this, and these are random records. So I'll just go back to df.head. Now it will give me idea about my features. These are the columns, and this is also a column, and we have identified as part of problem that this is the target column and these are features. And this target column is also called dependent variable, and these are called independent variables for obvious reason that this is dependent on these columns. Now what is this 0, 1, 2, 3, 4? This is the index. This panda is automatically giving index to these rows. One more interesting thing in pandas is, let's see, df.info. With this info, it is giving me just summary of this data set, and we know this. There are 500 entries, 0 to 499, and in each column it is telling me whether any row is blank or not. The interesting point to note over here is that it is automatically deciding the data type on the basis of the value which is available in the column. So because we have decimal values, it is giving float values, and pass fail also contains 0, 1, so it is giving int value, and it is also showing the size of the data set. If there would have been any value with a categorical value, it would have assigned it the data type object, which we will see in later data sets. Let's also analyze at a very high level statistics of this data, explore data. Right now I am not going with any graph. What we will do, we will simply use panda method, which is df.describe. Now see the beauty of this method. It gives you complete statistics. Of course, I am sure you must be aware about it, but let me just reiterate. Statistics contain few values like count, mean, standard deviation, min value, value at 25 percentile, 50 percentile, and maximum value. And then when you deep dive into statistics, there can be more value, but for now, panda, this describe method from data frame, panda's data frame is giving us what we need right now. As we can validate, it has 500 values, which we already know. The extra information which is getting is mean. So as we know, so mean of study hours, if we sum up all the study hours of the student and then we divide it by 500, then we'll get this mean. So mean in general gives us a fair idea of what kind of study hours may be there, right? Let's say we have students getting scores in class, right? And if I say average score is 60, so you will get the fair idea what a typical student, an average student in a class may look like. Similarly, we have previous exam score mean, right? And this holds no significance, so we will just ignore it. Standard deviation. So standard deviation formula is again coming from mean. If you want to dive into detail, you can refer to my tutorial on statistics. So standard deviation is, we have a mean value and then we have raw values, right? So standard deviation is how a typical value is deviating from the mean value. Minimum value, the minimum study hour noted in the data is 1. Minimum score is noted as 40. If I divide all the students into 4 equal parts, I will see my numbers at 25 percentile, 50 percentile, 75 percentile. If I divide all my study hours into 4 equal parts and I mark 25%, see the 25th, let's say there are 100 records, and if I see the 25th observation, that is 3.17, I mean sorted. Okay, so first I divide it into 100 equal, first I sort the data and divided it to 100 equal parts. It gives me the intimation that yes, first 25% students or study hours have this value. First 50%, which this value is also called median, has this value, and so on, and we can see maximum is this. So we can also see the difference between maximum and minimum. We can see that study hours are in the range from 5 to 9, while exam scores are in the range 68 to 99. So now we have loaded and validated data. It's time to do ML modeling. And those who have little insight into machine learning process must be wondering, what about data cleaning, data preparation, categorization, encoding, scaling, all those steps? What happened to those? And I would say wait and pause and let's see what is the need of them when we do ML modeling. And at this point, I would also like you to encourage, if you have not started with your keyboard and fingers, to immediately get into action, because just watching is just a wastage of time for you and me as well. Just watching this tutorial won't help, only action will help you to learn machine learning seriously. Now let's move to ML modeling part. So first of all, what is model? Model here is any algorithm which will help us to do, in this case, classification, right? Which will help us to solve our problem. And what was our basic problem? Our basic problem was that we have some existing data, study hours, previous exam score, and we have a labeled data whether those students who studied this much had previous exam score, passed or failed. And we want to feed this data to our, which will internally identify the relationship between these independent variables or features and the dependent variable. How this target is dependent on that, whether linearly, on whatever manner, whatever algorithm, in whatever way algorithm works, it will decide the relationship between these. And eventually when we give it a new data, let's say a new student comes and we add a record and we do not have this label, we have just study hours and previous exam score data for that student, we should be able to come up with the prediction whether that student will pass or fail. That's our problem statement. And to solve this problem, we will be picking up very basic model over here, very basic algorithm over here, which is called logistic regression. And this algorithm is a very basic model which is especially used in binary classification problem. And let's see how we use it in Python. And to use it in Python, we have to first import the library, and to import it we will use import from sklearn.linear_regression, import logistic regression. From linear_model, import logistic. And at this point, you really don't need to worry about how this model works. For that, you really need to know a little bit of maths, and we will come to that gradually. Let's see how this takes action, okay, practically. So we have imported this from sklearn library, this linear model which contains this algorithm. And what we will do, we will create an instance of this. Now this is our buddy, right? Remember, we had a buddy in our previous lecture to which we fed data and it learned, right? So we will be feeding data to this as well. So we have created our buddy, which is LR model, and now we need to feed data to this. What we need to feed? We need to tell this that what are our features and what is our target variable. And we have nowhere identified, though we know from the part of problem that this is our target variable and these are feature, but we need to tell this, right, before we feed this data. So we need to break our data into two parts. One is target variable and the other is features. And how do we do that? We will define capital X, because capital X is supposed to be a matrix, so we will define it with capital X. Alright, so capital X is df dot how we are including all the variables and excluding target variables. So we are just using this data frame method from pandas of draw, and we are saying columns is equal to, we want to drop this pass fail, right? We will obtain features from this, and target variable is represented by small y, and it is just one variable, right? So we are just representing it with a small variable y. Okay, so we will say df, and this is how we access a column from a data frame, and we know that it is pass fail. Now coming to our buddy LR model, we need to feed data to this. And how do we feed data? We feed data with the help of fit method, and here we pass that these are the features and this is the target. What this fit method will do, it will identify the relationship between these feature and target variable based on the logistics of logistic regression algorithm. We are done. Now, what is the problem here? It has created model and we need to wait for some new data to verify how this model is performing, whether it will do right predictions for us or not. We do not have any proof. We have just trained our model. Analogy to this can be derived from our previous example, where we trained a dog to tell that this is bone and this is ball, and we never show a new ball or bone to that dog. How can we make sure that we have trained the dog well, right? And we have trained our model, and we don't have any unseen data to validate the performance of this model. We need to make arrangements from the existing data. And you know how we can validate? If let's say take an example of a teacher student, right? Let's say teacher asks a question to a student and student answers. Teacher can only validate when the answer of student, if teacher knows the answer by oneself, right? This data is already available with us. Let's have a look at this CSV sheet again. So what I am trying to convey over here is that we have this whole data set, right? And we know that who passed and who failed. What about a trick where we divide our data into two parts, training data and test data? Some of the data part, measure of the data chunk, can be used to train this model, and some of the part can be used to test the model. What we will do during testing is that we will simply hide this value from model, which is trained model. We will just show the values of the feature and ask the prediction from the model, and then we will match whether with this actual values whether this prediction is right or not. That will validate the model, right? Let's see how we will be doing. To split data into training data and test data in Python, what we will be doing will be again using sklearn library with module dot model underscore selection, and we'll be importing train underscore test. Then we will go to this part where we are fitting the model, right? And on the top of that, let me just add one text over here, and we'll go on top of this and we'll do train test split. So what we are doing, we are splitting our code using this x underscore train comma x underscore test, y underscore train comma y underscore test. So what does that mean? X underscore train, when it means, as the name says, x underscore train represents the data set which is splitted out of x, all the values of features which are part of training sample, and then all the values of features which are part of test sample, and so is the target. And we will use train test split. And what we will pass over here, we will pass the original data, we will pass the target, we will pass is test size, how much we want in training data and how much we want in test data. So generally the ratio is 80-20 and test size is 20%, so we will give 0.2. So let's run this. Now let's have a look at content of x underscore train using head, and we get these values. Just notice them closely, and the head values contain 14, 67, these are the row numbers, these are the features, and similarly we will have a white train head also. If I run this again and again observe the training data, the first 5 values, these are changed. Now what is the problem here is every time I am running, it is randomly picking 80% of data for the data set. Every time it can change, and the problem is with the reproducibility, and this can impact the performance results, right? And we want to be consistent. So for that we will use random underscore state. Just add any number, whatever comes to your mind. I'll just add 42, and what will happen? Let's run it. So it has picked some random values from the data set, and these are the first 5 values of training data set. Okay, now I'll run it again. These values are not changing. So with the help of random underscore state, we are able to reproduce the same results in train data and test data. Now what we have to do? We have to update the model fitting part, and this time during fitting we have to just tell the model about the training data. Still it will be doing the same thing, identifying the relationship between features and the target variable and coming up with a fitted model, trained model, but this time we have kept aside some data for validation. Let's see how we do that. So we have this, right? And now is the time to predict the values. And to do prediction, we'll create one variable, y_pred, and we will take our trained model and to call predict method, and we'll pass just the features and not the values of the target variable, which is y_test. Okay, it has done some predictions, and we have kept aside validation data, right? And we'll add the code here. Let's just do a raw validation before we do talk about any performance metrics. Just do a raw validation. What I know, y_pred, I'll just fetch the first let's say 5 values of 5 predicted, and it gives me that the values are 0, 1, 0, 0, right? And then I will also fetch the first 5 values of test, which is actually the actual values. So we can see that only one first value is wrongly predicted and the other values are rightly predicted. That means the model has rightly predicted that this particular student is going to pass and these are going to fail, but for this it is a wrong prediction. It says that it is going to pass, but it says that it's going to fail, but our actual data says that it is going to pass. Let's talk about little bit about performance metric. So this is just a raw validation, but we can use performance metrics, different metrics for different kind of problems. This is a binary classification problems, and we'll just pick one for now, and that is accuracy. And to do this performance evaluation, we will again import one library, again from sklearn, metrics, import accuracy, and let's create a variable accuracy is equal to, and in this accuracy score we'll call y_test and y_predicted. I think it is we'll call y_pred and y_test. So actual values and the predicted values, and we'll run it and we'll just print it. It says 0.86, 86%. What does that imply is that out of all the data, 86% prediction is done correctly, and this is a very basic performance evaluation matrix for classification problem, and this might not be holding good value when we will see in the future when we will talk about performance metrics which can be confusion matrix, precision, recall, F1 score. We'll talk about it. Before I declare this script to be done, although I know that there are so many things which are left to be learned as part of data preprocessing, but it's just an introduction. But still, I would like to go back to one section, which is exploratory data analysis. While we will realize the need of exploratory data analysis over the time, in a gist, the primary use is exploring the quality of data, understanding the distribution of different features, understanding the relation between features and its relation with the target variable, and ultimately feature selection. Also preparing data for the machine learning modeling is the use of EDA. And when we do it through graphs, we understand it better. So what I'll do, I'll introduce you with the basic visualization over here. Graphs like histogram, bar plot, and box plot, scatter diagram. If you want to explore in detail what these graphs are all about, you can also go to my tutorial on data science statistics. Let's just see how we can implement it over. To do so, we will be importing a couple of libraries for data visualization, and the primary and essential library is matplotlib. So PLT, just to assign it a short term. The other library is Seaborn, which gives you more interactive and visually appealing and more flexibility graphs, but it is based on matplotlib itself, and again creating alias of that. Let's start by exploring data. First of all, we will explore target variable using bar plot. So target variable is, we can see, is having two values, 0 and 1, where assumably 0 stands for fail and 1 stands for pass. It's just my assumption. Before even we visualize, let's see how we can find the counts of each data type, and that is through a method called value underscore counts. Okay, and even if I simply run this, I can see that there are 316 values associated with 0 value, 0 and 1 value is associated with 184 records. Now to visualize the same data, bar graph is the most appropriate, right? We need to visualize against pass fail, 0 value and 1 value. So I'll be using same value counts, and I will use dot plot. Kind is equal to bar, and let's see what happens. So I get this kind of graph, right? So for 0, as we can see, 364. Not essentially, we can also change skill, but we get a rough idea through this that yes, this is not a balanced distribution, but not a very imbalanced distribution. Creating plot with the help of data frame functionalities itself, but it is under the hood using matplotlib. And once we are using this PLT, which is matplotlib, is storing whatever the current graph is, and we can assign various things to it, like title, right? We can do multiple modifications like title, distribution of pass fail. Okay, maybe we can assign X label also, PLT dot X label, which can be pass fail, and then we can use PLT dot Y label, which is count, right? And we can do multiple things. For now, let's stick here. So this is a bar graph. The other kind is histogram, which we can use to particularly to see the distribution of continuous variable. So continuous variable here in this case is a study hour or exam score, which applies that it can have any number of values, any digit is possible. So for that we will be using histogram. Let's say we want to see the distribution of exam score, we can use histogram, plt.hist, and within that we can give the, so with just passing this column name, we get this kind of distribution, which creates bin. Although we cannot see the lines of distinction or edges of these bins, and it automatically tries to give a number of bins as much as whatever is good for the data. And we can define our bins, let's say 5. Also we can define the edge color. Edge color is equal to black. Okay, so we get this distribution. And if we look at this distribution, we can make it more fine. Let's say we create 10 bins. Okay, what we get, distribution is almost, it is bimodal distribution, we will say. And bimodal, two values are occurring in more frequency. And what are those two values? It's around 50. Most of the kids are getting a score in the range of, let's say, 70. This is how we can see the distribution of continuous variable, and this is histogram. Next type of graph is scatter plot. Scatter plot can be used to see the relationship between two continuous variables. Let's see how. For now we have only two continuous variables, and those are previous exam scores and study hours. This time I would like to make use of Cmon library, SNS scatter plot, and there we pass the x and y. So let's say x is study hours, y is exam scores, data is equal to df. plt.show, we'll do plt.show. Okay, we can also make use of a very nice parameter called hue. And in hue, let's say we pass one categorical variable, and here we have pass fail, right? Alright, so as such, it seems there is no linear relationship between previous exam scores and study hours, because they are scattered all around. But for sure we can see that students with higher study hours are in pass group, and students with lesser study hours and even with more study hours are in both pass and fail group too. Definitely that makes sense that to pass we have to study for higher number of hours, but we can fail too if we don't study smartly. Right? So that is how scatter plot works, and it is used to identify the relationship between two continuous variables. Now let's also learn about one more important graph, and that is box plot. To draw box plot, we will be using Cmon box plot, and here we will be passing again x and y, and here this time x we have our categorical column against which we want to check the values of continuous variable, let's say study hours, and I have to provide data also. So I get these two values. Now let's have a look at them closely. What kind of information we are gaining from box plot. So if you see, 0 stands for fail, pass stands for 1, right? And for 0, this is the data distribution of study hour, and this is for distribution for pass study hour. And these are whiskers, they mark the minimum and maximum value. This marks the 25 percentile, this is 50 percentile, 75 percentile. So if we take study hours of all the failed people and sort them out in an order, and we cut the range at 25, 50 and 75, we will get this kind of box plot. And we can see that minimum of study hour of failure is quite low than that of pass, and we can also see that maximum are almost overlapping. That means even those students who studied for higher amount of time, as you saw in scatter plot also, were failing. And there are no outliers as such over here. What are outliers? I've already talked in my statistics tutorial, and this is median, right? 50% of the students are lying in this range, like 4 hours for failure, and in this case around let's say some 7.5, right? So this is the information which we can get from box plot. There are other many plots as well, but these are the primary plots which we will be often using during our machine learning programs to do exploration of data, visualization of data. And these are not just limited to find out the relation. We will see when we will be using data sets with high number of columns and variety of features, that how we can make use of EDA to see if the data is meeting machine learning algorithm assumptions, okay, which we will be talking in our next lecture, some of them. So stay tuned and subscribe to the channel to keep on learning.